All right, this is our last chance to review for the unit test. So, sequences and series review. Okay, so all along, just remember what we've kind of been working with is sequences, which is when you just have a list of numbers that follow a pattern. So the idea behind a sequence is it's just a list of numbers. Then we also have a thing called a series, which is the sum of a sequence. So that's a series is when you add them all up. Okay, so now beyond that we have a couple different things that you gotta know about. You gotta know the three types of sequences we have. The first one that we talked about was recursive. The idea behind a recursive sequence is it is one that uses the previous term to find the next term. Okay, so that's the recursive one. The second one that we have is we have an arithmetic one. And that adds or subtracts by the same amount each time. So if it's going up by 3 or down by 7 every time, that's arithmetic. Third one is geometric. Geometric is one where you multiply by the same amount each time. Okay, so that's geometric, is when you multiply by the same amount each time. So let me back up. So let's first talk about this idea behind a recursive. Recursive formulas use the things that they use is things like a sub n, which is the nth term. Might be the 47th term, might be the 13th term, might be usually for recursive we only go up to about 4 or 5 because you got to know the previous one. Remember a sub 1 is the first term. And remember a sub n minus 1 is what we're referring to as the previous term. So when you're doing a recursive formula, usually the way the example works out is it might be find the third term if maybe a sub 1 is equal to 4 and a sub n is equal to 3 times a sub n minus 1, something like that. So if we're trying to do that problem, best way I've kind of talked about doing it is I've said, really make a table. Make a table. Put n here, a sub n here. So when n equals 1, a sub 1 equals 4. When n equals 2, we would have 3 times 4, or 12. When n equals 3, we'd have 3 times 12, or 36. And we could keep on going. But notice what happens is we use the previous term in the new one. Again, later on, we use the previous term for the new one. That's a recursive one. It uses the previous term to figure out the new term. The next thing I want to talk about is I want to talk about an arithmetic one. With an arithmetic one, when you're talking about a sequence, it's going up by the same amount. There's a thing called an explicit formula. Explicit rather than recursive. Recursive uses the previous term. Explicit finds it's a rule to find any term so long as you have an n value. Okay, so as long as you have an n value. So what I mean by that, before I do that, for an arithmetic sequence, the nth term is equal to the first term plus n minus 1 times the common difference. That's how you find an explicit, that's an explicit formula for an arithmetic sequence. You need to know the first term, you need to know the common difference. The kind of thing that would happen with this is something like the following. Here's an example. Find the 10th term for this. And let me make it a series. Let me just put commas here. Sequence. So if you're going to find the 10th term, we know that a sub 10 is equal to the first term plus, let me back it up, just make a general rule, n minus 1 times the common difference. The common difference in this one is going up by 3 each time. So times 3. So then if you just wanted to figure out, well, what's the 10th term? All we would need to do is do a sub 10 is equal to 2 plus 10 minus 1 times 3, or 2 plus 27, or 29. So it's a really powerful thing. We don't need to know the previous term to use an explicit formula. All we need to know is some pretty basic stuff. For an arithmetic one, we need to know what's the first term, what's the common difference, and then use the whatever term, the nth value we're trying to figure out. Now, for an arithmetic series, remember that's the sum of the terms. The formula goes like this. A sub n is equal to a sub 1, sorry, wait, back up, is equal to n divided by 2 this is the sum the first term plus the nth term. So if we take our last example and let's say we wanted to find, let's say on this we needed to find the sum of the first 10 terms. In this problem that we had up here, we knew the first term was equal to 2. We knew the 10th term, because we just figured it out, was equal to 29. So when we find the sum of the first 10 terms, we do 10 divided by 2 times 2 plus 29. And then we're going to, whatever that equals is the sum. So that's for an arithmetic one. You got, for an arithmetic one, I don't think I can blow it out far enough, but for an arithmetic one, if you look back at what we did, there's the explicit rule. You really want to kind of have that somewhere in your notes, because that's really going to be an important piece. And then the sum formula can be in your notes for an arithmetic. Those are the two formulas you need. If you have those two formulas, arithmetic series and sequences should be fine. So let's move on to geometric. So when we're talking about geometric, we're talking about a geometric series or sequence for the explicit formula. For a geometric one, the nth term is equal to the first term times the common ratio to the n minus 1. That's for the sequence. So if we know, maybe we do something like this. We do example, find the 10th term of the following thing. Maybe I do 2, 4, 8, 16, and so on. So if we're going to find the 10th term, we know that the rule would be 2, which is the first term, times this one. In this particular one, this is being multiplied by 2 each time. So it's being multiplied by 2 each time. So we would use 2 to the n minus 1. So remember, in this problem, r is equal to 4 divided by 2, or 8 divided by 4, or 16 divided by 8. It's whatever the one term divided by the next term is. And that's what we get for r. So if we wanted to find the 10th term, a sub 10 would be 2 times 2 to the 9th. And then we just calculate that out. Now for a sum. For a sum of a geometric sequence, it's a little bit more involved. So for the sum of a geometric series, here's what you need to know for that one. Here, let me write this out. So for the sum of a geometric one, you take the first term times 1 minus the common ratio to the nth power divided by 1 minus the common ratio. So really important when you're going through this one that you kind of mind your formula and really know how to use it, and use parentheses and put it into a calculator appropriately. Because if we take this last example and we find the sum of the first 10 terms on this one, our formula S sub n would be 2 times 1 minus 2 to the n divided by 1 minus 2. So if we wanted to find the first 10, we'd put 10 in for n and calculate it. If we wanted to find S sub 10, we would do 2 times 1 minus 2 to the 10th divided by 1 minus 2. I'd encourage you to try that on a calculator so you type it in correctly. I'll do it as well. And you should have gotten 2046. Okay, the last thing we're going to talk about, and I don't know if we'll do an example, but we're going to talk about sigma notation. For sigma notation, here's what you need to know. You have this big sigma letter, which is a Greek letter, but it stands for summation. There's going to be a piece here, and right in here. So the parts of this is the start, this is the end, and this is the explicit rule. Okay? And this stands for sum. This is the sum. So we need an explicit rule, we need a start and a sum, and so it'd be kind of like if I gave you an example real quick, 2 plus 4 plus 6, we went up, we know this is arithmetic, we know our rule would be the first term plus n minus 1 times the common difference in this one. So, and maybe it said find the sigma notation. So if we did the sigma notation on this, start out with n equals 1, go to whatever number you want, maybe for the first 47 terms. How about that? To 47, And we have 2 plus n minus 1 times 2, and that would be our answer. Hopefully this helps. Take a look at go back and look at these notes again if you need to, but then take a look at the review exercises and come to office hours if you have questions. Good luck.